Hello to viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about humanoids are coming in 2025. So let's dive deep into it. Now, before you understand the whole context of what is going on, you have to understand this was always the dream. Meaning, if you watch old cartoons, old movies, old fiction, science fiction books, all of them had the idea of humanoid bots. Meaning, back in the older days, our logic was that we're gonna make a robot that is a full human body that just a machine. Basically, it's a person that is just a machine. That's what we were thinking about, and this is a very old dream, as in like ancient kind of dream. And the reason would be reason for that was that a machine could do everything a man can do. Like if a man can do this, that's all you have to ask. You do not have to, can a machine do this? No. If a man can do this, that means this machine would be able to do it. The end. And here's the right now we went into a different world. Basically, this was the dream, as in like, the science fiction dream, but reality was that we were not there yet. As in, if you wanted your car factory to have hundreds of humanoid robots building your cars, that was not doable yet. So what did we got? We got huge robots, basically custom built robots. Basically, there was a robot whose only job was collect this sheet metal, put it in here, get the, stamp metal done to it, pull it out, hold it steady. Second robot that will do welding, and these robot will be only able to do that thing, like take sheet metal from here, put it here, take it here, put it here, and it will do it for millions of years. But like that was the reality. We were shaping the world around it so it can work. For example, our dreams were like we're gonna have a robot that is vacuuming things. What we got was a vacuum cleaner that was moving. So our perspective on things changed. Basically, back in the days, we were thinking like there would be a robot that will sit on the driver's seat and is gonna use everything. You do not have to tamper the car. But what we got was car that had every sensor. Basically, it had lidar, radar, ultrasounds, cameras, boatload of cameras with some extra cameras, and then some more cameras. Then we put bonkers amount of sensors. Drive-by-wire. Most cars are already drive-by-wire. So that was the easy part. Drive-by-wire was the easy part in cars because again, even it's the steering, even though it's a mechanical link, there is a steering motor. So that was the easy part. Everything else was the hard part, basically the processing. So we were shaping the world around so AI, robotics can actually do things for us. And this dream of having a humanoid body solves that problem. Meaning you just have a humanoid, it does everything. So you buy one robot, it cleans your house, does your laundry, and drives you around, all of that. And it can even work in factories. So that was the whole dream that we wanted. Basically, all the tools would just work. Oh, this is the drill. Done. You do not have to build a custom attachment that can do it. No, it's just a drill. Go home. So, and the hope was that we would not have to do unwanted chores in our house. Like there are a lot of chores that we have to do. And if you look into the olden eras of like, kings and kingdoms, that's how you knew somebody was rich, because they had people doing menial chores. Like somebody else was writing letters for them. Somebody else was folding clothes for them. Somebody else was cooking food for them. Like, a lot of, unwanted chores that somebody else was doing. And here you can have a robot do it for you. So the idea is optimistically that middle class to upper middle class should be able to do everything that a king can do. Meaning, of course, they will not be like, owners of multi-billion-dollar corporation, but they would be able to live like a king. Live like a king. Let that be, live like a king. Meaning they have things done for them. So that was the dream. That is the dream. And that's why people are still trying to make a humanoid body. And again, Terminator, I don't have to tell you more about it, and iRobot. So that was the idea. That's why humanoid form is desirable. Now, okay, if that is that desirable and that ancient, why haven't we built it? Well, there was sort of limitation, physics level limitation, or to be more precise, engineering level limitation. Meaning, we never had the tech, like fully cooked tech to do it. For example, the best example I can see was Honda's Asimo robot that was launched in year 2000. It was good for that time, but the price, and again, I like recently was looking into it, I was like, price was like, damn, how much money you burnt into this? And it kind of made sense because they were way too early, 20 years too early. So first we tried with hydraulics. That's why the James Cameron robot looks like, hydraulic and all that. So hydraulic, what does hydraulic have? Power. Terminator power. But it's huge. And again, you can see Boston Dynamics also tried with hydraulics. It was huge. And again, you can see some of the older training video. They have that, like it jumps, it breaks something, and pss, hydraulic leaks. So it's big, it's powerful, but it is slow. And precision is like, sloppy. So people are like, okay, what if we use pneumatics? Basically, you have air muscles. And again, that was desirable because you can have the muscle structures almost exactly like human muscle structures. So a lot of people were seriously looking into it. Problem is, while pneumatic is very fast, that's the good part. It's like Bruce Lee level fast. That's the good part. But it's sloppy and loud. And again, even if you solve the loud part, it is sloppy. Meaning, if I am like stop my hand here, my muscle can do that because muscle has a feedback loop. Pneumatic does not have that kind of feedback loop, even if you try. Because why? Air is inherently temperature dependent and compressible. So based on the force and all that, like it's not hydraulic. Is like, bro, go. But like pneumatic is like, you can try, but like, it's inherently cheap, but like it is cheap in motion control also. So that is there. Motors are fast, so you get Bruce Lee speed. They are very precise. That's why your CNC, 3D printer, and the whole world works. That's the good part. They are fast, they are precise. Power not as strong as hydraulic, but decent. Like let's just say it is enough to do enough things. However, they were very messy. And that's why Boston Dynamics started with hydraulics. Now their current model is motor, because again, all the mess required was not sorted yet. And this was the hardware part. Again, DARPA was trying to solve the hardware part, but problem was compute was nowhere near. Meaning, once we actually tried to replicate humanoid body, we realized our brain is the reason we can stand and walk. Like this puppy is doing a lot of computation in the background just so you can stand like this. And be mindful, you are not actually standing like this. It's somewhere like this. Like your body is actively falling and then it's trying to calculate. That's why your feet have bonkers amounts of muscle. And that's why bipedal geometry is so rare in evolution. Like that puppy is complex. And we just did not have enough computer horsepower. And that's why you will see Osmo robots and the robots in the back in the days, they're always like, crouched knees. That was the easiest way to, stabilize it. So we needed many things to cook before it was ready. Let that be very clear. Like principles were there. Engineering started to work on it, but it was not cooked. So things changed. Like what changed from year 2000 to now? Well, opportunities. Now the biggest opportunity was ChatGPT. Now whether you agree with ChatGPT or not, like it or not, it was a massive thing. Basically, it's almost like an iPhone moment. So it changed the game in 2022. Meaning people went from bots to AI, and that spike where it was like, whoa, AI is real and AI is here. Now again, let that be very clear. I do not give a damn about how good it is or how useful it is. It's real. Again, it's not precise, but assume it's a toddler that is 5 years old. Now compare it. So it is real. And what did it mean? Money started flowing, and money started to flow in two domains. First, AI, and another edge AI. Edge AI is very important here. So the idea is AI means you build ginormous data center and you train bonkersly complex mathematics to create a neural set that works. So that was for training. And then smaller units where you can run it on a local device without requiring a net, meaning on-board neural networks became a reality. That's why I said two vectors. AI, as in like NVIDIA will build ginormous data center that does the crunching and creating the brain, and then brain will run, basically the algorithms will run on a small hard device that is in your thing. Like a lot of people are saying, oh, that means what happens if the net goes down? Nothing. If they're running on edge AI, nothing happens if internet is there or not there. The only thing that will change is basically the telemetry uplink. Basically, the telemetry it's sending out there will not work. That's done. That's not an issue. Of course, you may want to have like a downlink to have emergency shutdown and all that, but inherently it's not we have to have server connection. No. If you're doing it right, you will use edge AI, and edge AI would be self-contained. So that's the point of it. And of course, updates and all that and training and more improvements, those will be done on data centers. So that is there. And that sorts the brain part of it. Now, what happened to the hardware part? Development of driver electronics has went bonkers. Like all the development in drones, gimbals, electric vehicles, microcontroller, it created a scenario, meaning right now you can have an electric motor that is this big. It is powerful. But here's the deal. Back in the old days, like let's say year 2000, you could have the same motor, same neodymium magnet motor, same copper, same bearing, everything. Here's the driver electronics would be this big, bigger than the motor itself. And you can see that in old robotics, they used to have motor, and they are giant driving cabinet was like G motor driver. Motor was not that powerful. It was just driving was so difficult. Now, same motor, same NEMA size motor, the driver electronics can be on the back of it. While it is being more efficient, while it is being cheaper, while it is being more precise. all that became possible. Like I was looking into basically motor driver electronics. Right now there are companies who are selling, because back in the old days, if you wanted to microcontroller to drive a BLDC motor, it was expensive AF. And then it was like, okay, I have the microcontroller that will do the driving, then I'll have MOSFET drivers, then those MOSFET drivers will have like a lot of passives, and the amount of circuit board you needed. Now it's like, buy this, put it, go home. Like the passive count is like, 5 or 6, and it's simple passive, like not like, okay, charge pump and all. No, just some bypass resistor and diodes and all that is like, go home. It's like, how the heck that's possible? Like, how the heck you can do all that in freaking silicon? And we are doing it. It's like, bro, we do not even care. Like, mathematically we knew how to make gimbals, so why didn't we make gimbals in 90s? We could not miniaturize the electronics. The motors were the same, neodymium was the same. It's just that we did not have the PLC algorithms that could work on a small enough hardware to be handheldable. And let alone, even if you did that back in the day, it would not be affordable by anyone. Even NASA would be like, bro, yo, we can't afford it. So all this parallel development that happened, be it drones, be it gimbals, be it electric vehicles, microcontrollers, all of this created a scenario where price came down and it became epic. Meaning now you can actually think of this and make it. Like this became, oh, we can do it actually. It's not just like, it's like, hey, wait a minute, we can redo this, and better and cheaper. So that's why this opportunity matters. And again, the money that is falling in, that means venture capitalist money is coming in, meaning super cheap, low cost loan without putting collateral. Then the company can't be collateral. You are making the company with the money. So it's not like a land, it's like a, virtual. So that is there. So opportunity bonkers. So we come to today, as in Mark 1. Many companies are selling humanoid robot. I'm pretty sure you must have seen a lot of Chinese companies that are like, we have $5,000, $10,000. And again, if you have seen the NVIDIA's presentation, they had like, we have hundreds of humanoid robots right this point in time. So price point is around $50,000 or below. That's the sweet spot everybody is targeting. And how much is that money? Well, again, money is inflation based, so it could change. So think in this way. It's a decent size electric vehicle. Not the best, the latest and greatest electric vehicle, nor the cheapest electric vehicle, but decent size. So similar sort of monetary horsepower is required. So that's how you can calibrate it in future if you're watching that video. So basically it became as decent size car, like not the cheapest car, but not the most expensive car. So, and the biggest change was going from basically factories to common life, so to common public life. Now, why is that a big deal? If you look into robotics that are made for industry, those are precise. They are powerful. They are absolute units. They're like, done. So that's cool. That's what they need. That's why they built it. The end, go home. But here's the deal. When you bring the same philosophy into basically humanoid life, yeah, it does not work. Humanoid life is completely different. This puppy has to be adaptable. It has to be modular. It has to be flexible. Basically, antithesis, basically what makes an awesome factory robot makes horrendous humanoid robot. So completely different ball game. So that's a good thing. And Edge AI actually is optional, but again, if you are smart enough, you will make these things on Edge AI. And if you ever wondered why the heck NVIDIA randomly went from $4 trillion to $5 trillion, because all of this robotics, they have basically Edge AI hardware from NVIDIA. Most of them have Thor. So that's why. Internet is what you call a remote feature, meaning in this robotics design, the once you ask your robot to do something complex, it should have enough intelligence. It's like, I do not understand it. It will phone home, and there will be a person who will try to either walk it block by block or actually override it and do it in remote. So that would be doable. But at this point in time, while the hardware is there, like, the motors are there, the actual brain is also there. It's just that the software in the brain is not there. As in, like, the brain is not trained. Like the best you can see, they are like a toddlers. They are not cooked. As in, like, the software is not cooked. So, for example, human robot, like basically the home robot, it's not ready. What they are selling is just not real. They are selling you the hardware. Is that real? Yes. Can it move and do all things? Yes. Can it actually just work? Do this? No. There has to be a person. Now, okay, then why they are selling on a fake dream? Well, they're hoping that or they may have some good algorithm behind the scene, which they are like, bro, if we can just give it enough training data in this exact constraint environment, it might be able to actually just self-learn. And once they have enough units sold, let's just say thousands of units sold, they should have enough data like collected that over time they will have exponential growth in capabilities, and voila, it actually does the work. So That's what they're hoping for. Right now, the hardware is awesome. And I really like the idea that A, they designed it such a way that you can hug it and it will not feel very threatening. Second, they drive motors via ropes. Basically, rope is there. Now, why is rope? Because again, it's almost acting like a tendon, and it has that sort of flexibility while being rigid enough. Like, is it rigid? Yes. Is it flexible? Little bit. That little bit of give makes it far more what you call delicate, while having enough force that it can do some heavy work. So that was clever. Another part is low noise, and I'm pretty sure the systems have very low noise, and the chassis that they have on top of it, it's almost acting like a sound deadening layer. So the 22 decibel, it's impressive. Heck, our computers can have more noise than that. So that's a clever thing that I have to respect. Whoever the mechanical engineer is, like, bro, we understand. It's not like, um, Elon Musk hype is like, no, it has to be something that is quiet. It has to be something just blends in and you do not have to worry about. Although that would be creepy part of it. If it ever somebody hacks it, says like it just slowly creeps at you, you will not hear it. So it's a double-edged sword. But again, hardware is definitely unique and definitely going in the right direction. But the AI is not there. Let that be clear. The hardware is there. And again, that maybe we found out in the future, 5 years from now, though the let's say teraflops that this puppy had was nowhere near as much as needed, or we may find out, oh, it just took like few years of iterations where it's like, no, this hardware can work. That would be amazing. Like, you imagine you had this and 5 years down the line they have like final patch update and it's like it's exponentially better. So this is Mark 1 right now. And again, you can see all these robots, while they are very good, but if they fall, they flap around like a toddler. They cannot unsolve that issue. It's like, oh, you fell, solve this issue. Okay, unsolve it. Like, do not do the same thing again and again. So that's still there. Like, hardware has the power. Hardware has the power. It's just that the AI does not understand how to undo it. It's almost like a cockroach. Once you flip it, it's like, it's there. So this is Mark 1. This is what is available right now at the end of year 2025. So what can we expect in the future? Well, reality is we are entering in a true new age. As in, last few years, we would have felt almost the same. Like, oh, we had internet, duh. Oh, we had smartphone, duh. Like, there was nothing, what you call momentous change, so to say. It was like cooking. We are making things better. Like, okay, when I was young, I got my ADSL internet that was like 2 Mbps. Now 150 Mbps. Again, even if I get like 2 terabyte per second, it won't be like, whoa. Because again, the not having an internet to 2 Mbps, that was like, whoa. From 2 Mbps to 150 is like, and 150 to like, going to like 2 terabyte per second is like, not that like, whoa. So this is completely different. This is like, this did not exist. Now it does exist. So that's a very big thing. Now, this is a true test of AI. Right now, AI is literally working in a constrained environment. Does it actually have the horsepower to learn and grow? And we say, no, self-learning AI and like self-refinement, feedback loop, are those real or just like hulululu? It's like, that's the whole testing of it. Is it real? Is it able to learn? And again, right now, the capabilities of these robotics are just copy-paste, meaning a trainer will train it, do this. When somebody asks this, do this. Cool, awesome. But it has to go away from that. Like, it has to go away from copy-paste instruction. It has to be able to handle it. If not, ask the person itself is like, hey, how should I do this? And like, what steps I have to, and then interpolate it. And, because when you're talking about soft things, you can't have rigid instruction set. It has to be flexible. So we'll find out. Like, this year, the upcoming years will be the testing ground for actual working AI of 5 years. Let's just say from 2025 to 2030s, we'll figure out whether we have AI and it's actually capable enough to learn and adapt. That will be sorted. Now, is there anything positive coming out of this? Yes, this will be amazing for elderly care. Why? Well, 150 countries have decided to shift delete themselves, as in birth rate is below 2.1, as in there won't be enough people to take care of the old people. So having this would be really amazing. So that's a very good thing. And again, I do not want old people to suffer meaninglessly. And again, right now it's bad. It would be exponentially bad in the upcoming future. So it's better to have basically saving strategy right now. And there is enough need and demand. Those parts are sorted. So AI bot and all that, those are not likely to print money. This is likely to print money. This is the next normal thing, as in like car companies. Why did it become so big? Because they made car a normal thing that everybody has to have. This is the next car, as in like everybody with middle class or upper middle class should have this. So need is there, demand is there, that is there. And you're like, okay, the most important technology of the humans. girlfriend bot. That is far. Let that be very, that is very far. Now again, studying these two things side by side will give you a very clear understanding how the heck this could be $20,000 and this sort of very rudimentary robotics. Like even calling them robotics is like very, what you call, over exaggerating, because again they are not even at the level of animatronics that are available in Disney World. So how the heck they are so expensive, like $100,000 versus $20,000? Well, this is the difference between for profit and from venture capitalists. These people are running on free money from venture capitalists. These people have to make their money from the units they are selling. So the price is somewhere between these two, somewhere in between these two. So I would say a humanoid robotics like this should cost somewhere around $30,000 as of now. Now again, does that mean this robotics would be super expensive? No. As this thing becomes far more what you call common, and you're like, okay, what about patents? Patents expire in 20 years. So I can easily see, and be mindful, if you're seeing the hardware now, that means patents are generally 5 years old and sometimes 20, already 10 years old. So not that far away. So all those patents will expire, more newer hardware will come, and once enough production is there, as in like production for motors, rope drives and all that jazz, making this would be exponentially easier. And again, they do not have the, what you call, luxury of again, no venture capitalist is gonna like, oh, we are investing money in lovebirds. So it will take time. Let that be clear. This robotics will happen first, then it will go to this. Although benefit of this company is that they are working their ass off to be cash positive. Of course, I'm pretty sure somebody would be pouring some money, but this is like free money, like billions of dollars. This would be like, if they're lucky, millions of dollars. So it's a big thing. But again, I would say have patience, my man. It's only 10 years. If I'm really downgrading it, like you want like absolute life sorted kind of bot, that is at least 20 years away. You have to wait for patents to expire. Lot of patents. You have to wait for them to expire and come into public domain. But again, potential is there. Hardware is there. Things are moving in the right direction. So future is going to be very testing. Like the next 5 years would be testing of AI, like who can actually cook an AI that actually does things. It will be fun. So this was my presentation on basically the humanoids are coming. Hopefully you have liked it, learned from it. In that case, please click the like button, share it among your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.